What we got today? We got segment and angle addition postulate, our EQ. How do I find the lengths of segments and measurements of angles? All right, pretty simple. We're going to try and understand the basics of segments and angles today, and we're going to be talking about coordinates, congruency, constructions, and then midpoint, bisect, segment bisectors, vertex, and degrees. Okay. So, vertex and degree. Yeah. Now, here we go. Coordinate, the location of a point. Very simple. The location of a point, like on the coordinate grid. All right? I gave you the point 2, -3. I went on a coordinate plane. I go 2 to the right, 3 down. Keep in mind that the first, this is written as X, Y. The first number tells me to go left or right. The second number tells me to go up or down. Okay. Okay. Congruent means identical measurements. Identical measurements. Okay, I want to make sure I get this on the record. All right. I promise. This doesn't sound too condescending. I promise is this. You do not know what congruent means, you will fail this class. At the end of this class, you don't know what congruent means, you will fail. You cannot make it through this class without understanding congruent. Okay? It's impossible. That means that you're not trying. Okay? I'm going to say it, and you guys will repeat after me. Congruent means identical. Congruent means identical. Let's try one more time. Congruent means identical. So what does congruent mean? It means identical. It's equal. It's absolutely the same. Okay? Absolutely the same. All right? So check it out. We're going to have this balancing game between what's similar, what is congruent. Okay? Similar, congruent. Okay? Somebody, anybody. What is the red thing? What shape is that red thing back there? Yeah, it's a rectangle. Okay? It's a rectangle. Somebody help me out. What is this big block thing right there? It's a rectangle. Okay? Here we go. That's a rectangle. Yeah? This is a rectangle. Yeah? Okay? Are they similar? Yeah, they're similar. Okay? They are similar, they're just different sizes, right? Okay? Are they congruent? No. See that? No, because they're not identical. This one right here and this one right here. Are those similar? Yeah. Yeah, they're similar. Okay? Are they congruent? Yes. See that? Okay? All right. So that is, I mean, if you get that concept, you're getting about 30% of the class. Okay? It's just, yeah, we're just going to do it over and over and over again, different shapes. Same thing with circles. Same thing with rectangles. Same thing with triangles. Same thing with squares. Everything you can imagine. Okay? That's what we're getting at this year. So congruent means identical. Equal, the exact same. Okay? All right, what is a construction? It's really simple. A construction is just a representation of a segment, an angle, or a shape. Representation of a segment, an angle, or a shape. Okay, we'll use construction, we'll do construction using compasses, and pretty much it. Okay. Compasses, straight edges, we'll figure out how to construct segments, construct angles, construct bisectors, construct parallel lines. We'll construct some shapes. We'll do triangles and circles, circles and a triangle, squares and a circle, octagons, hexagons. Yay! Okay. We have a few lessons on that type of stuff. I don't do too much on it because Scarborough will poke the guy out with compass. You okay? Alright, everybody got that? Alright, here we go. This is the big one. Midpoints. Bisect. Segment bisector. The midpoint of a segment is the point that bisects, and that just means divides the segment into two congruent segments. The segment connecting the midpoint is called the segment bisector. Give me a second to write all that down. Okay, as you guys are finishing up writing, let me explain a little bit. Okay, we call the midpoint of a segment. Now, I don't think this is true, but y'all don't know that I don't know that it's true, so it's okay. All right, let's just say midpoint is short for the middle point, right in the middle. Okay. Okay, there we go. That would be midpoint in the middle. Okay, literally the exact middle. Okay, a midpoint bisects a segment, or it bisects a segment. Okay, so bisects. What the prefix of bisects is bi. What does that mean? How many? Two. What are some everyday life things? Bi. Yeah, so why does everybody always say bisexual? Okay, why can't we go like bisexual? Bipolar. You know, bilingual. See, we have to say bisexual. First thing that always comes up. What do you like? Bisexual? All right, whatever. Okay. All right, so bi means how many? It will split. So bisects means splits, divide, right? Splits into two what? Congruent parts. Okay? So do I have to say it again? What does congruent mean? Identical, equal, the exact same, right? Identical, the exact same. So a midpoint takes a line segment, splits it into two congruent segments, right? And then we put it together and we get a segment bisector. That's all a segment bisector means. Take a segment, cut it in half, whatever the halfway point is called a segment bisector. Why not? Pretty simple, right? We'll leave it that simple and make it a little more complicated, right? Very good. All right, degree. Measure of an angle is given in degrees, typically. Okay. Sometime in the future, you'll learn about radians, but I'll let somebody else do that for you. Okay. And there are if there are 360 degrees in a circle, 1 degree is how much of that circle? It's a fraction. What is it? Yeah, 1 over 360, right? There's a total of 360. Okay, and there's one of those 360 that we're talking about. All right, let's talk about fractions real quick. Okay. All right. So in the past, you've heard top and bottom. Keep one, ACF. Keep one, change one, flip one. Right? Or whatever it is that y'all talk about. Okay, we don't talk about those things here. We use big people terms, right? Numerator, denominator. Which of these is the denominator? 360. Which one's the numerator? 1. All right. See how easy that was? Okay. Now, some of you can use what Miss Markham, your Miss Markham in 2nd grade taught me. Okay. Because numerator and denominator, those are big words back then. Okay. Right? Denominator. You know how to spell that? Yeah, it starts with D-E-N, and then it has omerator after it. All right? But it starts with D-E-N. What does D-E-N spell? Den. Okay? In your house, where's the den? Yeah, that's why it never works. Where's the den in most houses? Downstairs, the basement, right? Okay, we're talking 1970s split level homes, right? Okay, brain bunch, right, guys? Bins in the basement, okay? All right, hey, the basement or the bottom, right? Denominators on the bottom, numerators on top. So I don't play on bottom. Okay? So numerator, denominator. Everybody with me? Okay. Y'all know it? I won't make you spell it. Okay, that's cool. All right, numerator, denominator. Okay. All right, moving on. Good deal. Our first postulate of the year. Okay, so here's what you need to write down. Make sure you write down segment addition postulate. Okay, segment addition postulate. Okay, and then you can do one of two things. If you want to, if you're one of those people, you don't write anything down after that. I'm not gonna make it. If you're smart, then you'll write everything else down. Okay, if you're a definition person, there you go. That's the segment addition postulate. If you're a visual person, it'll help you out too. If you like one an A or a B, write them both down, okay? That's simple, all right? What is our segment addition postulate? Here it is. If point B is between point A and point C, then line segment AB plus line segment BC equals line segment BC. AC, I'm sorry, you're right, let me say it correctly. If point B is between point A and point C, then line segment AB plus line segment BC equals line segment AC. Okay, I know they don't have a line. Now they do. Okay. No, what the heck does that mean? I'm a math guy. Sometimes I think and can learn visually. Okay. Anytime we're talking about line segments, by golly, let me tell you one thing. You put a map in my place, we'll be all right. Okay. Here's why. I need a town nearby that starts with an A. Oh, perfect. Atlanta. Okay. Here's Atlanta. Okay. I need a town nearby that starts with a B. Bremen. Perfect. Okay. We'll do Bremen. And to make this one a good one, I need a town in Alabama that starts with a C and is on I-20. Coleman? Good. Anybody know anything? Anybody from Alabama? Cleveland County. Cleveland County. Calhoun. Yeah. Calhoun County. Sure. There we go. Calhoun County. Okay. Whatever. Cleveland County. I don't know. Whatever. Whatever's over there by that. Okay. All right. Here we go, guys. Here is, if you want, here's the segment addition postulate. How far is it? Take a guess. From Atlanta to Bremen. 40 miles. Good call. Okay, we'll just say it's probably more. We'll do 50 miles. Let's say it's 50 miles from Atlanta to Bremen. Let's say from Bremen, Georgia to Calhoun County, Alabama. Bremen to Calhoun County, 60 miles. Fair enough? Okay, 60 miles. All right, probably not geographically accurate, but I don't care. Okay, all right, here we go, guys. From A to B plus B to C equals A to C. So how far would it be from Atlanta to Calhoun County? 110. How did I get 110? 50 plus 60. Don't see that? Okay, that's not right. I mean, you're like, is this really geometry? Yes, this is really geometry. This is an actual thing that you have to learn. Okay, so how will you see it written? You'll see it written like this. The whole deal, A to C, would be 110. Okay, with me? I got a problem up here that we're going to work together. Here we go. G is between F and H. F to G is 6, F to H is 11, find G to H. First tip of the year. Okay, first tip of the year. Here we go. True or false? This is a word problem. True. What makes it true? Are there words? Is it a problem? Word problem. Good. Okay. All right. It's got numbers too. I know. All right. This is a word problem. Anytime you have a word problem, draw a picture. First tip of the year. Not a requirement, just a helpful tip. Okay? First tip of the year. Word problem. Draw a picture. Check it out. If you want to make an F in here, don't read the problem. Don't draw a picture. You'll be good. Okay? If you want to make a C in here, kind of read the problem and maybe draw a picture and maybe try and put some numbers down, and you'll probably make a C. If you want to make a B in here, read the problem, draw a picture, work it the wrong way. You'll probably make a B. Okay? If you want to make an A in here, read the problem, read it again, draw a picture, check to make sure that your picture is accurate, solve the problem. That's simple. Got me? Let's pretend, let's assume, everybody wants to make an A. All right? All right. G is between F and H. All right. What's the first point I'm going to put down? F. Why is it F and not G? F does not tell me what I need. I'm sorry, G is between F and H. Starting with F will help me out the most. Does this picture illustrate F, G, H? Does this picture illustrate that G is between F and H? Yes. All right. So far, so good. And we're going to add some dots and lines. How far is it from F to G? How far is it from F to H? What is the question asking me? So you can do one of two things where it says find G to H in here. One of two things. First thing you can do, put a question mark. Second thing you can do, put an X. What kind of people are y'all? X people or question mark? Don't put question mark X, okay? We'll just put that for now. All right, when I put in the equation, I'll do it the right way, okay? All right, hey, you'll see how this is the same problem asked a different way, right? You got me? The total distance, F to G, G to H, F to H. F to G plus G to H equals F to H. That's the geometry, right? Now let's turn it into the algebra. F to G, that's 6, plus question mark. Well, we don't put things in question marks. We put an X, equals 11. Subtract 6, and you get what? See how easy it can be, right? X is 5. You can check your work. Is 6 plus 5 11? Is 11 equal to 11? If it's not, then I quit. You want to give me one thing? Any questions on that? Yeah, it's not fun. Okay, maybe not a step too far. Okay, I got you. Oh, take a couple minutes. Take 2 minutes and set up your work. Okay. N to M plus M to O equals N to O. That's the geometry. Right? That is literally what you wrote down. Segment addition postulate. Correct? The whole thing's a segment. It's broken up into parts. Add the parts together, you get the whole thing. That's all things math. I mean, it's complicated. Okay, add some numbers. 17 plus 3x minus 5 equals 5x plus 2. Check your work. How'd you do? Did you set it up right? Okay. Maybe, right? Okay. If you didn't write anything down, you're in the F to C range, F range. Okay. If you wrote it down, but maybe it's wrong right now, B to C range. If you wrote it down correctly and you're waiting on me to solve it, you're in the A to B range. If you already passed it, then you're good. Right? First step, combine like terms, right? You got to CLT it. Okay? CLT it. Combine like terms. So in my football days, it's CLS. Okay, on the backside of an outside zone play, if you were tied in on the backside of an outside zone play, it's CLS, C gap linebacker safety. Okay, it took me a long time to get CLT out. Combine like terms. Cool. What are the like terms on the left side of the equation? Got me? 17 minus 5 is how many? 12. 3x plus 12 equals 5x plus 2. Okay? Right? Okay? And I lied to you the very first, right off the bat today. I said I'd never do one of these again, but I'll do it. I'm a nice guy. I thought I'd do that. Unless you don't want me to. Y'all want to know the answer. I'll tell you. Okay, 7. And right or wrong. Right? 5x is bigger than 3x, so I'll move the 3x's to the right. If I move the 3x's to the right, I know I'm going to be moving whatever was on the right side, and it didn't have an x with it, I'll be moving it to the left. So, you know, in like Algebra 1, they tell you don't do those things. Here in geometry, okay, I don't care if you do it all in one lump sum or not. Right? Here we go. 3x is 0, 2's are 0, 12 minus 2 is 10, 5x minus 3x is 2x. I've done all the adding and subtracting. Now I'm ready to multiply or divide. What am I going to do here? Let's divide both sides by 2. Okay. What is 10 divided by 2? Tyler Scarborough. Did you get 5? You did. Tyler Scarborough. If I asked you to solve for x, would that be the right answer? Yes. If I asked you to plug that in and find NO, would 5 be the right answer? No, it wouldn't, right? See what I'm saying? It depends on the question I ask you. If I say solve for x, that's all you got to do. If I say, hey, use that and find NO, take 5 times 5 plus 2, right? 27. See? There's a difference in the questions, okay? I picked on Tyler, I'll pick on somebody else next time, okay? All right, like right now. All right, here's the next one. D is the midpoint of EF. E to D equals 4x plus 6, and D to F equals 7x minus 9. Find E to D, D to F, and E to F. E, D, F, E, F. Okay. All right, so there's a key word in there. Hold on, man. I'm about to tell you, it starts with an F and it ends with it. Okay, what's your name again? Traylon. Traylon, what's the definition of midpoint you wrote down? Midpoint is what? Dissect. You wrote dissect. Okay, because remember, yeah. Into what? Yeah. Why is that important? What's congruent mean? Identical. And if it's in an equation, what would that mean? They are equal, right? See that? Traylon did a great job. I don't know if everybody heard him, so I'll repeat it. Because it tells me that D is the midpoint, okay, that means that this entire line segment is split into two bisect. It's split or divided into two congruent segments. Okay? And it might seem really small, go, Mr. Hobbs, but here's why that's important. If it's congruent, then it's equal. Right? If it's congruent, it's identical, it's the same, it's equal. So to solve this problem, I have to take this segment and set it equal to this segment. 4x plus 6 equals 7x minus 9. Right? Now, take a minute and a half, solve that equation. Oh, go ahead. Look, guys, listen. I'll be like, who had Coach Murphy? Never mind. Okay? Listen. Everybody can do this part right. Subtract 4x from both sides. Add 9 to both sides. 3x equals 15 divided by 3. 5 equals x. Right? But like Scarborough told me last problem. Check it out. Is that the question that I asked? Does that answer the question? So, tip number 2 for today. This class really isn't so much about how hard the math is, right? That's very simple math. You'll get that, right? Come on, y'all been doing that for years, okay? That's simple math. That's not the hard part. This class is about the following. Did you answer the question that I asked? Does this answer the question that I asked? No. What do I got to do with all that? I got to plug it in. The question I asked was, what's ED, what's DF, what's EF? Scarborough, did you get 26? Did you get 26? Did you get 52? Well, boss, what's 26 and 26? Well, it is, right? So here's the answer to the question I've asked. E to D, D to F, E to F. 26, 26, 52. See that? Your EOC. Okay? Your EOC. Have a question like this, it will say, what is E to F? Right? One of the answers will be 5. If you're not paying attention, you'll select 5, and you're wrong. You're as wrong as it all can. Get it? Got me? I told y'all first day. It's not. It's a different class altogether. Okay? Are you answering the question that was asked? Okay? That's why I mentioned with your mind, right? Okay, we got one more major thing we got to talk about, right? Angle addition postulate. Write this one down too. Angle addition postulate. Hurry up, I've only got 2 shows. Okay, here we go. I gotta hustle. S is in the interior of angle PQR, then the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. What did you have to let? Do it and draw the picture. I will exemplify this for you. Keep writing. All right, check it out. I'll do this problem as you guys write all that down, okay? All right, here is all the angle addition postulate basically means, okay? I started off with one big angle, PQR. Okay, last week we talked about how to name that angle. We can name it angle PQR, angle RQP, angle Q. Or, Maddie back here. Go Roxy. All right. Or I could name it like angle 1. All right. If, remember we call these rays? If I add a ray to this big angle, then the measure of the two angles that create the big angle is equal to the measure of the big angle. All right? Really hard to define this. It's much easier to solve it. Let me use this example. The measure of angle DEG is 115. The measure of angle DEF is 48. I'm trying to find the measure of angle FEG. Check it out. Just like my postulate tells me, the measure of DEF plus the measure of angle FEG equals the measure of angle DEG. Okay? So far, so good, right? I'll say this again. That's the geometry, right? That's what we just wrote down. That's what we defined, okay? Now let's add some algebra to it. How much is DEG? 115, right? How much is DEF? How much is FEG? We don't know. See that? Plus X. See how easy that was? All you gotta do. Okay? How do I solve for X here? One-step equation. Subtract 48 from both sides. What's 115 minus 48? Ooh. Go without your phone. Come on, boss. Hey. You take 8 from 5. Nope. Let's borrow that. 15 minus 8 is 7. Can you take 4 from 0? Nope. Go to the bank. 10 minus 4 is 7. Is that hard? 67 degrees, right? All right. Now, if I put 67, does that answer the question that was asked? Scarborough, what question did I ask?
What is FEG?
Is this FEG?
Yes.
So is this answering the question that was asked? See how confusing it can be? Yeah. Right? Okay. This answers the question that was asked. Right? We got one more. New problem. You guys work it on your own. Okay? Work it on your own, then we'll get you. Ooh, I didn't get a break yet. Okay? I tell you what, take 1 minute. 1 minute, 1 minute, 1 minute. That's all you need here. I promise. 1 minute. Especially if I come up here and do this on the board. Uh-oh, 25 seconds. What did you get? 62. 62. 62. Right on. 62. Scarborough, does this answer the question that was asked? Sure does. Sure does. Any questions on that? Cool. All right, guys, you got 4.5 minutes. You're on your break. You can do whatever you need to in the next 4.5 minutes. Your assignment is on Edmodo. It's classwork number 3. So whenever you would like to, you can get started on it.